So who am I? My name is Nikirk. I'm a second-year security major at RIT. I am the current WESIS president. I'm also WeirdOS lead for ICS. I'm on the red team. Previously was on the ops program. I'm an incoming software engineering intern at Apple. I previously worked at MITRE. Really enjoy writing software, mostly malware, but some other non-malware related things. And I really like table tennis and Kubernetes. So for the talk today, the title is Down the Pipeline, but before we can talk about the crazy thing that pipelines are, we have to talk about DevOps. So DevOps is basically a set of practices that combine software development, so the dev side of operations, and IT operations, or ops. And basically the entire goal is to shorten the system development lifecycle and provide continuous delivery with high software quality in shortest time possible. So I mentioned the system development lifecycle. What is that? See this nice little diagram. However, that text is really small and it's kind of hard to read, and also like it's a big circle with lots of arrows. That's kind of confusing. So let's go explain that. So the first part is analysis. This is basically the stage where you are finding out what the system currently does and what your customer needs from you. So this could be, say, your tasking is to, here's a good example, scale your CTF deployment. You're currently looking at what your current infrastructure can do and what we need it to. The second step is the design phase. So right now, our current system, it can't fit the scale needs that we need it to do. It can't handle like that heavy of traffic. So we need to make it so it can scale better. So we basically take our new requirements and we create a solution. We're like, I think that running it on Kubernetes is going to be great, and we're going to do that. And yeah. So here's the implementation phase. It's pretty self-explanatory. Basically, you finish your design, and now you actually need to start building it. There's this funny little meme. It's basically talking about, how in the actual implementation phase, sometimes your little tiny design gets like a whole bunch of dependencies and it didn't really pan out how you wanted it to. So the testing phase. So our solution is now actually built. Now we need to make sure it works. So we ported over our CTF stuff to Kubernetes. Now let's actually make sure that it can scale and handle all the traffic that we need it to. So that's this. And now finally the installation phase. So it works. Now it's time to actually deploy our solution. 9 times out of 10, this is sometimes maybe not the easiest step. And it can get pretty difficult. And then the documentation phase. So we've actually installed it, we've tested it, made sure it works. Now it's time to actually document our solution so end users can actually use it. Because otherwise, what was all the work we just did, right? And then the evaluation and maintenance phase. So this is something that's pretty important in a whole bunch of projects, but basically, you get to the whole end of it. This can happen in like Black Team. We have our little Black Team debrief basically at the end of comp, and we gather in a room and we take basically all of the feedback and all of the lessons learned, and we compile that together. So for next year's and next projects, we don't have to repeat the same mistakes over and over and over again. That's basically the step. So you may be wondering, Ashley, isn't this a DevOps talk? Weren't we supposed to be talking about pipelines? And the answer is yes. So DevOps and specifically pipelines integrate at every single level of the system development lifecycle. And I'll be explaining that. So for DevOps, there's a whole bunch of tooling for this process called CI/CD, continuous integration, continuous development. You have stuff like Jira, Jenkins, CodeShip, New Relic for like monitoring, JUnit for testing. If you take in GCIS 124, you probably use JUnit in there as like a testing framework. But that's like a lot, right? There's too many tools. How are we going to, remember all of that? This is a short presentation, so let's try and shorten this up. So we're gonna do it GitLab style, all right? So GitLab is self-described as the one DevOps platform. It's basically a software package that combines the ability to develop, secure, and operate applications. or operates software in a single application. So it has a lot of the features that those other tools had, so like Jenkins, JUnit for testing, except it does it all in the same little application, which is pretty cool. So let's look at the analysis and design phase, right? In GitLab, we have this really nice feature called issue boards. Basically, this allows us to check what our project currently can do and what we need it to do. And you can track that using Git issues, which is really, really nice. And it tells you exactly what's done and what still needs to be done. There's also milestones. So milestones is a better way of tracking the actual entire project. And it gives you a really, really clear view of how close you are to your deadlines and how like things are going along. Then you can see like who everything is assigned to and such. Implementation phase, this is, if you recall, when we're actually like writing the stuff and doing the coding. So how does this play into GitLab? Merge requests. So merge requests are basically when you submit a new feature, you do your git add, git commit, git push, and then you try and merge that into the new branch, because you should be using branches if you're doing development, guys, right? We all use branches. And you're pushing code for a new feature. So what was this about pipelines? If you go back in the last slide, you see pipeline pass. You know, what's all that about? But these are a key component of GitLab and this thing called GitOps, or you know, sometimes people call it DevOps CI/CD. But it basically allows for automation of testing, documentation, installation, and a whole bunch more stuff that is way outside the scope of this talk, but is also really, really cool. So here's a brief overview. This is what it looks like in GitLab. You can see the status, the pipeline, the commit message, who triggered the pipeline. So say you have like a malicious actor or like a dumb developer and they are pushing to your main branch, you can see exactly who triggered that pipeline, which is pretty useful. It's very similar to like git blame. And you can see the stages of it. So this is something you'll learn later on, but pipelines have multiple stages. And each of them will pass in concurrent order. And if one of the earlier ones fails, it will not trigger the rest. So the ordering becomes pretty important. Here are the components of the individual jobs. So you'll see they have a status, pass or fail. They have a job ID, which helps you identify the specific one. They have a pipeline ID showing which pipeline they were like attributed to, the stage they were running at, the name of this like, you know, task it was trying to complete, and then how long it took. So here is sort of the code that defines how the like CI/CD pipelines are running in GitLab. This is called a GitLab CI YAML file. YAML is just a language to describe, you know, a whole bunch of things. So similar to like JSON, it's just a markup language. So you can see in here you have the stages, test, docs, build, deploy. That's what you'll see in the most simple of pipelines. And we can see here it's doing run tests, right? So that's the phase we're on. There's a couple components of this that are important to note. You can specify an image that you want it to run on. Otherwise, the runner will just pick its default base image. And then script is really useful because that actually allows you to run the commands that you want to do in that stage. So for this instance, it's installing a virtual environment, grabbing the requirements, and then running PyTest. PyTest is similar to JUnit. If you took 123, I'm pretty sure that's what you use as your Python testing framework. And it'll run your tests. If this fails, none of the other steps in the pipeline will trigger, which is pretty useful and is a base indicator that you have messed up something. So this is really cool. No more manual testing, test on push. It's very clear when new changes break the code base. And you can imagine how this speeds up the system development lifecycle very significantly because you can have basically absolute knowledge of whether or not that this push, this commit, is going to break or not break your system, which is pretty cool. So here's some more code. This is for the docs phase. So you can see here, pulling an image, Python, it's building the documentation. And then one thing to note here that's pretty cool is these like basically containers it spins up. the tasks are being given to a runner from the pipeline. And all of the like containers it spins up are ephemeral, right? They're basically getting created and destroyed willy-nilly. And so if we want to retain anything from that, we have to specify it. So in this case, I've done a specification here called artifacts. And it's pulling from this path and then basically putting it in next to the pipeline or whatever. And there's a little download button, and you can download your documentation, which is very cool. So here we see, you can download the artifacts, and then if I actually pull up the documentation, you can see it automatically built that for me. And that is pretty swag. So there's automatic versioning of docs now. There's no need to manually build your documentation, and it's literally always available. You go on the project, you just click on the last pipeline that triggered, download the docs, simple as that. So this is the build phase. So for a lot of applications nowadays, there are these things we called microservices. Microservices are basically these singular applications that do one thing. And typically they're containerized. So Malik did a really, really good talk earlier about Podman and talked about containerization there. So I'm not going to explain it for you unless anyone's confused. Everyone know what containers are? Show of hands. Yeah. Okay, awesome. But basically, it's going to build our Docker image for us. So we have a Docker file actually in the repository, and it's going to build it, and it's going to push it. And this allows us to then pull it down in a later phase. So we can see it's going to Docker Hub. It just pushed, 24 minutes ago or however, and we have the latest image in there. So here's actually the deploy phase. So you can see in here some kubectl stuff. This is using Kubernetes, which I'll explain later on. But all you need to know now is that after we've uploaded our image, we're now actually deploying it. So we're refreshing whatever was in there with whatever changes we made, and it's going to basically pull down the new image, restart the deployment, and then we can use our new application. And then this is the installation phase. So if you actually go into the box, you finish your pipeline, you want to see that everything's working, you can test that. So I'm curling the local IP. The application I gave as an example and that you'll see later on the demo is a simple Python Flask app that's returning this thing called base response when you curl the main page. So you may be asking yourself, what is Kubernetes? I know you mentioned that in the last phase, you were doing like k8s deploy. Well, it's an open source container orchestration tool, very simply. And it's used for automating deployment, scaling, and management of containerized applications. If you're more curious about this, there was a very good presentation done on WeSys on Wednesday, and there are slides posted on WeSys meeting slides where you can learn way more about this than I'm going to describe in here. But this is all you need to know for now. And Kubernetes is actually extremely, extremely critical for CI/CD. If you look at any big tech company, any actual production environment, they're going to be using Kubernetes in their CI/CD pipeline. And basically, the typical flow, as we saw earlier, is you push to the repo, the CI/CD pipeline triggers. Your agent then picks up tasks that's running on the cluster, and it'll then run those tasks. So your build, your docs, your deploy, your testing, all that kind of stuff. And it will redeploy your application to the Kubernetes cluster. So let's go see that. Got a little demo for you guys. So one thing to note here, when I was actually running the demo, for some reason the build phase was not working. So we're actually going to do that manually before we actually run the pipeline to see that it's making the changes. But basically, I can go on here, and like I did in the slides, I can curl port 5000 and see that we're getting base response. This is just our application running. If I want to see that it's actually doing that, do kubectl get pod. This basically just shows us all the containerized applications running on the system. As simple as I can explain that. So let's actually go change this. So let's go into Better Terminal, and then this might be actually a little tiny. Can I set this down? I can't. Yeah. So all I did here is I just changed this to hello RATSec. So hopefully, if all according, goes well, we go back to our cluster and we curl port 5000, and we'll see hello RITSec instead. So we're going to build the image. So we go back here and we do sudo docker build .tecd sapphic RITSec and then latest. So this is going to build the image. Does everyone understand what was happening there? Does everyone know Docker build, Docker files? Feel free to raise your hand if you don't. I know I didn't freshman year. If you're not raising your hand, maybe some of you are liars, but that's fine. It's okay to be shy. You're a big liar, Kenny? Do you know what a Docker file is? I'm so proud of you, man. So now we're going to push that. So we do sudo docker push, and then RITSec, and then latest. So that's all fine and dandy. It's actually been pushed to the remote repository. If I went to Docker Hub, I would see that the latest image was pushed like 1 minute ago. So now let's actually trigger the pipeline. So the way in which you do that is you do a git add, and then, yeah, I edited this, right? Source views frontend.py. RITSec demo, and we do a push. And so you see here we've actually pushed it. And so if I refresh on the left, you see that this is the pipelines. And we can see that one has started triggering. So it's currently in the testing phase. So we can actually look at that. And then another fun thing is because I have, it's called basically a runner. This is the thing that's actually performing the task. And I have it running on Kubernetes. So if I actually do git pod and then watch, I can see it. And you see how there's now this like runner thing down here. It's actually spinning up containers to perform all these tasks for it. And you can imagine this is pretty useful. So how I was doing it before is I was doing it via Docker and just Docker Compose, and I had one runner that was going. Well, what if I have a team of 30 developers and I want them to all be able to use the pipeline? Well, what I can do is scale that, and I can have like 30 runners running. And so now suddenly you can run 30 concurrent pipelines, and that is pretty cool. Obviously, you have to scale up the resources with the pods, but say I actually wanted to do that, all you would have to do is, let me say the mic, you run this command, kubectl scale, and then the deployment. So in this case, it's GitLab runner, and then the number of replicas. So let's set that like to 2. So we see that it's actually scaled. I wish it was that simple for everything. And we do kubectl get pod, and we can see that 2 runners are actually running. So that's pretty cool. We've just doubled our efficiency, which is awesome. If we go back to the pipeline, we can see that the test phase ran, successfully. PyTest, 1 pass. It'll now go on to the next phase. So basically, if there is an error code, it'll just exit out. We can see that the docs ran successfully as well. It built all the documentation. We can download that. So now let's go to the deploy step. So if we go in here, we can see that it basically applied a new deployment file. All this does is it refreshes whatever was in there, pulls the latest image, and then we do a restart of the deployment. So if I go back here and I run curl and then on port 5000, you can say it says hello RITSec. And so obviously that's pretty cool. So that's the end of the demo. Unless anyone want to see more, Kubernetes shenanigans, yeah. So, in conclusion, why should we care, right? All of that was well, fine, and dandy. You said a lot of words, but why is this important? Well, it will deploy your application on push now, which is very, very nice. If you have done any kind of software development, you know that this process is tedious, right? When I had to do the Docker build and the Docker push, imagine that, but like 5 more steps. You have to do the testing yourself. You have to write the documentation. Who likes writing docs? And then you actually have to build the docs. It's just a lot, right? Well, now it just does it all for us on a push. We don't have to do anything as a developer other than set up, the pipeline ourselves. So this is pretty cool. It leads to extremely scalable deployments. So because we have it running in the cluster, like I was showing you earlier, you can just bump up the number of replicas. That's super useful. And all in all, it just shortens the systems development lifecycle like super significantly. That's why DevOps is applied at basically every single organization that does software, and it just saves a ton of time. So here's my contact info. That's my LinkedIn, GitHub, Twitter. You should totally follow those if you want to learn more about this kind of stuff. And yeah, thank you guys. Any questions? Can be about anything in the presentation. Kubernetes, you want to see more demo stuff, whatever. Anyone? All right, thank you.